Okay, today we get to look at section 6.5, and we are continuing graphing linear equations. Today we're going to use slope-intercept form, probably most algebra students' favorite form for graphing linear equations. And again, since they're linear, what shape do they look like when you graph them? Lines, okay? We're going to use this form, very famous form, called slope y-intercept form. Can you say slope y-intercept?
Slope y-intercept.
Good. Okay, so at this point you know the letter that is used for slope because you've been using it. And you did a really nice job on the quiz finding slope when you were given 2 points. And the letter we use for slope is?
M.
Like the mountains have slopes. So the equation for slope-intercept form is y equals mx plus b. Okay. And so m, there it is your slope. We also have 3 other letters in this equation, right? And 2 of them are x and y. And x and y together give us what? A begins with P? A point. So a point is found in this equation. And how many points are on a line? Infinite points are on a line, right? So there are infinite pairs of x, y's we could plug into a linear equation. So when we write the equation, we usually leave x and y open to all the infinite points that you could put in there, okay? M is something that stays the same no matter what point you put in. M will always stay the same. It's the slope, okay? And then B is the other number that will stay the same. It'll be a constant. And this is called slope y-intercept form. So if M is the slope, what do you think B is?
1.
It's called slope y-intercept. So if M is a slope, B must be the y-intercept. Okay, it's the y-intercept. So let's make a note of that. Okay, Gabe just asked, what is the y? The y together with the x gives us what?
Point.
A point. X, y together give us 1 point on the line. Okay? So as an example, we have a little equation y equals 10x plus 6. So you can see x and y usually remain open for all the ordered pairs that could work in here. There's infinite ordered pairs, okay? Infinite points that could go on this line. But 10 represents what? 10 is a slope. So this line has a slope of 10, and this line crosses the y-axis at 6. That's the y-intercept, okay? So let's make a note of that in your rule box and be sure to box that up. So the first little basic thing we can do is identify slope and y-intercept when you receive an equation that is already in that form, okay? I could also give you an equation that's not in this form, and you might have to change the equation, transform it to this form. But this is a starting place. So as we look at number 1, it says y equals 6x plus 1. Identify slope and identify the y-intercept. So you can simply say slope equals what, and y-intercept is given a b. It will be known as a lowercase b every time you see it. Okay, so we'll say y-intercept is, why do you think it's not a y? Do you see? That's right, there already is a y in the equation, and that y represents part of this point xy. There are infinite points that work in these equations, and so we don't want to confuse ourselves and call it a y. Okay? B is the y-intercept. So let's say it together. I'm sure that this is a piece of cake, right? The slope is
6x.
6, just plain old 6. It's the number coming before the x, okay? And the y-intercept is 1. Let's look at this one here. I think I have a second one here. Oh no, we'll go here first. Okay, so number 2 is a little bit different looking, isn't it? We know that slope-intercept form up here is y equals mx plus b. And as we look at number 2, it looks like y equals mx, doesn't it? It's short, like something fell off the end or something. So if there is nothing on the end, what could we add, but it would still equal the same equation, Spencer? That's right. So we kind of do that, and you may do that in your scratch work, right? And now we can simply say the slope is, good, 1/4, and the y-intercept is 0. It's not just nothing, it's actually 0. That's a place on the graph. If we look at my coordinate plane here, where does y equal 0? Right there, the point of origin. Good, you got it. Okay, here's a more advanced equation. Is this equation in slope-intercept form? No. So the first step will be changing this equation into slope-intercept form. And we did that. Haven't we been doing that? We've been isolating y, or solving for y. We've been doing that a lot. And so that's what we need to do now. Solve for y, and then look for slope and y-intercept. So what might be the first thing we could do to solve for y? Izzy? You said add negative 2x? So if I add negative 2x, is negative 2x plus negative 2x going to give us no more x's? Okay, so now she's saying subtract negative 2x. So subtract negative 2x. When we subtract a negative, we could change this to doing what? Add the opposite. So really, what are we doing here? Adding 2x. That's good. We're adding 2x to both sides of the equal sign. Right? And so negative 2x plus positive 2x gives us?
6 plus 2.
Negative 2x, positive 2x? 0. And we don't have to write 0 because there's something else going on over there. 0 plus 3y is 3y. Okay? And now who remembers what we're going to do when we write the terms on the right side? Do you remember this? Okay, Audrey.
Just 6 plus 2x.
You could write 6 plus 2x, but who remembers something I said? Brian. Good. Put the term that has the x closer to the equal sign. Do you see why we're doing that? Who knows why we're doing that now? Who knows why? Let's do it first. So Brian, tell us what it is. 2x plus 6. And so look at what we have. We have the x term closer to the equal sign, right? And look at what we're working on today. Slope, y-intercept form. So do you see the connection?
Yes.
In the slope y-intercept form, the term with the x is closer to the equal sign. So we can find slope super fast, okay? So finish isolating y for us. Gabe. What do we have to do? Good, we divide by 3. And remember, we divide all terms. When you divide all terms by the same value, okay? And we end up with y, 1y, 3 over 3 equals 1. So 1y, we let the 1 be invisible, equals 2/3 x plus, what is 6 divided by 3? 2. Okay, and so we leave it this way. We leave 2/3 as 2/3 because what does 2/3 represent? It is the slope. So m equals 2/3. And when we think of the R words with slope, slope is rise over run. So we would rise 2 and run 3 if we were graphing. Okay? So we don't change that to a decimal. We leave it in a fraction form. And then everybody, the y-intercept equals 2. That's what we have when we simplified this to slope-intercept form. Okay, go ahead and identify the slope and the y-intercept for number 4. You can come back and check your work. Pause the video. Okay, so we have our y-intercept, but for slope, we want to say, you know, what number is in front of a variable where you don't see a number? What number is it? 1. So we could slide that in there. And really, we do have a slope here, don't we? And the slope is 1/3. X is not included, just 1/3. Okay, you're gonna love this way of graphing, if asked to graph, because it's a little quicker than making a table with all these points, or even finding intercepts. Although finding intercepts can be kind of fast, so that's another fast way. But if you're given this form, slope-intercept form, you can graph it quickly. This says y equals 2x minus 5. So we're going to do exactly what we just did. We're going to identify the slope and the y-intercept. Okay? So everybody do it on your paper and then we'll check it. Okay? First step is identify slope and y-intercept. So let's say together the slope is
2
over what? When you don't have a denominator, what is the denominator? 1. Good. We like that. We like to have the denominator because slope is, with our R words, rise over run. Good. We want to remember that when we're using slope. And our y-intercept is just like what we just saw in the last one, huh? The y-intercept is -5. Okay? So here's where we get to graph. So when we have slope and y-intercept, do we have a point? What point do we have? What point do we have if we have a y-intercept? What point do we have? We have a -5. Remember the term intercept? It means a place that's on that axis, right? So your y-intercept is your starting point. It's really huge. That's your starting point. And it's a y-intercept. So we are going to stay on the y-axis and go to -5. And there it is, a starting point. And once you have a starting point, you now can use your slope from that starting point. You got to go from that point. Okay? And so here we are at the starting point, and we're going to rise and run, right? And how much are we going to rise?
2
1, 2. And how much are we going to run? +1. So there's a second point. And how many points does a person need to graph a line?
2
And we have them. As long as we were precise, we have them. We could continue using our slope from the second point. We could go up to and over 1 again, up to and over 1 again, up to and over 1. We could keep doing this infinitely, right? And sometimes I like to do a few more so that you can have a nice estimate of where the line should be. Okay? And now what do we do to finish? Draw your line. Good. So draw your line. And again, use a ruler or your little note card so it's nice and straight. Okay? Good. When we look at the equation here and what we found for slope, the slope is positive, right? And remember the little ant crawling on it? The ant can crawl left to right. Is the ant crawling in a positive slope direction? Yes. So it's a good thing to check that at the end and you know you're on the right track. Okay? Let's just put the steps down to graphing using slope y-intercept form. Okay? So got slope and y-intercept. If you have y equals mx plus b, slope y-intercept form, then what was the first thing we did? If you have that form. Okay, good. And then we graphed the y-intercept. That's the starting point. And then, Kenzie, what did we do after graphing the starting point? We started at that point and we used what? To find a second point. What did we use? So we used our slope to find the second point. And after having 2 points, we drew a line through the 2 points and beyond with arrows on both ends. So now you're going to use this, just as we did, to graph or to identify slope and y-intercept.